Hello guys. Yeah, back to school. Might not feel like it, but school has begun again and it's time to learn something. Okay, so this is about capacitors and how they can be connected. So there are two ways to connect any electrical device. One is the series connection and the other is the parallel connection. But first of all, let's have a look at what determines the capacitance. So the capacitance is expressed in farads, and it's depending on epsilon 0, epsilon r, the area, the voltage squared, and all of that divided by 2 times the length squared of the length between the two plates. So basically, the two things that we can influence through design is A, and that's the cross-section area, of the plates, and L, the length or the distance of the plates. Or the length between the plates. Yeah, so those are the two that can be influenced. Now, if we connect two capacitors, in this case we connect them in parallel, like this. So here's the first one, here's the second one. You can see, I'm marking this in a different color, basically this plate here and this plate here, they're connected. That one here and that one here, they're also connected. That means if we're drawing it differently, we can draw it like this. We can almost draw it like this. As they are connected, they can be shown as two plates of one capacitor. So what have we done? The distance here, L, remains constant. However, A has increased. Which means the capacitance also is increased. Yeah? Now, if we're going to look at the series connection, what we see is this. First capacitor, second capacitor are connected in series. Now again, showing you, this is the one plate. Yeah. This is the other plate. And this one is connected to this one. So they're acting as basically the same plate. And that one is opposing this one. Yeah? If you look at that, it means that A has remained constant. Yeah, active as the blue and the green. However, now L has increased. Because now this distance and this distance both together add up. And that means, because as you can see here, L is in the denominator of the equation, C consequently has decreased. Yeah? So if we're looking at a parallel connection of two capacitors, the overall capacitance increases. If we're looking at a series connection, the overall capacitance becomes smaller. And with this knowledge, we can now start to calculate the tasks. So now with this knowledge in mind, we can try to have a look at the tasks that were set for you. And according to what your results that you handed in, some of you had a bit of trouble, and therefore I'm going to do a calculation like the one that I just showed you, so you can get the correct results. And I'm going to do that in the next video. Until then, have a good night and see you. Bye.